Now, aluminium extrusion is a plastic deformation process in which an aluminium billet is forced to flow by compression through the die opening. This opening is a much smaller cross-sectional area than that of the billet. The extrusion die can have different designs: solid, hollow, or semi-hollow, each affecting how the aluminium is shaped during its journey through the die. The bearing, the last point of contact between the metal and the die, plays a crucial role in shaping the final product of the extrusion process. This figure shows the bearing of a solid extrusion die. This figure shows the bearings of hollow extrusion die. The reasons of uneven metal flow through a flat extrusion die can be the following. The frictional resistance at the billet container interface slows down the metal flow near the billet surface. The center of the billet thus moves faster than the periphery of the billet. To balance the flow, bearing length must be inversely proportional to its distance from the center of the billet. This figure shows three types of bearings: parallel, choked to slow the flow, relieved to accelerate the flow. Parallel bearings are the working standard. In this case, the flow rate of aluminium through the working channel of the die is adjusted by changing the length of the bearings. The methods of slowing and accelerating the metal flow trough the bearing channel shown in this figure. Choke at front of bearing to slow the flow. Relief at the back of the bearing to accelerate the flow. The results of numerical simulation of the resistance of the bearing channel of the die, depending on the angle of the bearing, are shown in this figure. The negative, relieved angle gives low resistance to metal flow. With an increase of the relieved angle, the flow resistance remains constant. When reducing the relieved angle for a small fraction of a degree to 0, that is before, as the bearing channel is parallel, the pressure increases dramatically. In the accelerating, relieved bearing channel, aluminium touches the walls of the bearing channel of the die only at its inlet, and then loses contact with the bearings. The increase of the angle, and also the length of bearing, no longer influences the metal flow resistance of the bearing channel. The slowing, choked bearing channel ensures the full contact of aluminium along the entire length of the bearing channel. A slight increase in the angle, at which there is full contact, almost no effect on the rate of flow of metal. The transition from almost no contact to the full contact occurs at the value of the angle about 0. And as always, thanks for watching. Remember to like, comment, and subscribe.